Hi, my name is Julio Miralles, and I'm here to talk about the two proportion z-test. And these scores are standard scores. The z-score states the position of a raw score in relation to the mean of the distribution, using the standard deviation as a unit of measurement. Basically, here's the examples of formulas that you could possibly use for samples and populations. This is an example of how the standard deviation and the z-score would look like, and I have examples that I have posted up with the formulas that I previously showed before. Why use z-scores? Z-scores make it easier to compare the scores and distributions using different scales. Like these two examples that I have, but it's comparing what the first trial happened and then the second trial happened. Here shows the different graphs that are being used by test A and test B, but they're two separate standard deviations away from the mean. Z-scores enable to determine the relationship between one score and the rest of the score using just one table for all normal distribution. If we have 480 scores normally distributed with a mean of 60 and a standard deviation of 8, how many would 76 or above be? Here's an example of the graph below. As I've shown before with the formula, I've used it right here and plugged in what I've seen from the distribution and the mean and the standard deviation, but we need to know the size of the area beyond z. Remember that the area under the normal curve corresponds directly to the proportion of scores. As the proportion of 1, 0.0228 of scores are likely to be 76 or more as a percentage equals to 2.28%. As a number, 0.0228 times 480 equals to 10.94 scores. Here's the z-score table showing us the information of how I plugged in all the formulas and the numbers from test A and test B and just plotted out a chart. How many scores would be for 54 or less? Graphing the problem, I've used the formula again to plug in different answers, but by ignoring the sign of z, area beyond z for 0.75 will equal to 0.2266. Thus, 22.7% of the score is 109 scores, are 55 or less. These scores would be 76 or less. Subtract the area above 76 from the total area. So 1.000, subtract that from 0.0228, it will equal to 0.9772. Thus, 97.72 of the scores are 76 or less. How many scores fall between the mean and the 76? Use the area between the mean and the z column in the table. For z, it will equal to 2.0. The area is 0.4772. Thus, 47.72% of the score lies between the mean and 76. How many scores fall between 69 and 76? Find the area beyond 69, subtract that from the area beyond 76, and it will give you your standard deviation, or yeah, the total mean. Therefore, find the z for 69, it will equal to 1.125. Area beyond z will equal to 0.1314. Find z for 76, it will equal to 2.00. Area beyond z will equal to 0.0228. 0.1314 will subtract that from 0.0228 equals that to 0.1086.